Hi, everyone. Yeah, starting. So hi, everyone. Thanks for coming today and happy Halloween. So today will be not the standard LEAP lecture. Instead, it will be a conversation facilitated by Robert Pincus. So Robert is a Lamont Research Professor in the Ocean and Climate Physics Division. He works primarily on problems in atmospheric physics, especially those related to radiation and to clouds. He leads LEAP's Data and Computation Working Group, which is the starting point for today's conversation. Robert, please.
Okay, so it's hard when you have this machinery. Okay, sorry. First of all, for those of you in Radio Land, Brian, Adisu, and other folks who I don't mention, and Hauja, hello. This isn't going to be a lecture at all. This is going to be a conversation about the LEAP's needs in data and computation going forward. So y'all are welcome to hang around. I don't know how easy it will or won't be. I'm looking at the computer screen. I don't know how easy it will or won't be for us to involve you in the discussion because I'm going to try and make this fairly informal. You're welcome to stay. If you don't stay, I won't feel bad. And neither will anybody in the room. Okay, so here's the story. As you heard, at least many of you heard at LEAP's annual meeting, we had a data and computation committee, and that was led by Ryan Abernathy. And one of the things that's happened is LEAP has matured, and we've brought on staff, and things have gotten up, so staff like Julius and like James. And the project has matured is that the needs for sort of supervision and oversight have diminished because people are doing their jobs. And so the question is, what can we do better? So there, just the status, the status would look something like this. And you guys heard this at the annual meeting from Julius. We have a LEAP Pangeo computational platform that amounts to a whole bunch of credits in commercial clouds and a Jupyter Hub with a variety of possible backends that we can use to do some category of calculations. We have, through the hard work of Julius and many others, built this data catalog that provides us access to a fairly wide number of and fairly diverse set of data sets that we hope are of wide utility. And we have Wayne's effort. Where did Wayne go? There he is. We have Wayne's efforts, where he's painstakingly tried to make CESM and I guess E3SM work with ML models, and that's still not mature, let's say, right? So that's the status of where we are, and so we want to do kind of two things with this conversation. One of them is to find out about what needs are being met and what needs are not being met. And so I have some questions related to that next. And if I have to stand up here, I'll go a little crazy. So I'm going to hope that people will pipe up and maybe come up and write on the board and stuff like that. The other is that we'd like to nucleate. We had affinity groups, right? We had these affinity groups that were topical, about parameter estimation and about ML-driven parameterizations. And what we want to think of here is something, I was calling them community of practice. I talked about this with Tian a little bit, but just basically the idea of groups of people who are solving technical problems and can learn from one another. So I have some ideas that I would seed, but I'd like in the second, 50 minutes of this thing or whatever it is, we'll do some solicitation first and then quickly move to these communities of practice. The idea is to develop groups of people who all have the same pain points and get you all together. And the advantage of doing that is not only do you learn from one another, which is always the best part of graduate school and postdoc, but also sometimes the center has resources. And if there's something that we need to do, we can do that. So if there's people we need to hire, tasks we need to fund, or hardware we need to buy, these are things we, in principle, have the resources to do subject to priorities. So I have a question. I want to know who within when you are doing research that is related to LEAP, do you always use LEAP Pangeo? And if not, what do you use and why? That is my question.
Hey,
I want to take this stupid thing off, if that's all right.
Yeah, I think that's probably better.
Yeah.
Thanks.
This
I just wanted to give a little background on the class too,
oh yeah.
because it might, and I'm doing it now because it might craft the conversation. So at least half of the students in the class are not affiliated with LEAP at all. Now, it's possible they might become affiliated with LEAP, or they might learn about a topic in LEAP that they might want to pursue more. So that, maybe we should keep that in mind. But one possibility also, and I've run into this recently, is, and this could also encapsulate some of the students here, is the temporary access to resources on, to LEAP resources. Whether that's computing, it could be working, as part of a summer program, like RAU or the Momentum Fellow program. It could be for class. So in some of the things, even though it's temporary, it could feed back onto LEAP, of course. We never know what would happen from that. So I wanted to just say that because, there are a few in here who are not affiliated with LEAP at all, but might have some interest in using LEAP resources. That's all.
This has come up in the past, actually. So then how can we make this conversation useful to those of you in the class? James, it's that I took the thing off because I was hearing my voice. I think that's okay.
That's gonna be bad for the online folks. Maybe
Well, Brian just dropped off.
there's a microphone up there, so it should be fine.
Oh, I still hate these things, but fine. I just basically hate the sound of it. Right. So maybe the question would be, so are most of the students, maybe you know this, or you guys can, shake or nod your heads. Are you involved in machine learning or other kinds of computational projects in your research?
Or maybe best to say, raise your hands if not.
Yeah, raise your hands if you've never had to do a large scale calculation. Oh, okay. Is this because you guys are relatively new, or because you do stuff with pencil and paper?
So yeah, some new, right? And also, but you might be interested in doing that, right? That's why you're here. So
Yeah, okay.
yeah. So perhaps some of the things you're interested in might craft what thinking ahead.
Can I ask of y'all then, do you have experience using sort of cloudy resources? So Jupyter hubs, or can I get a general nodding or shaking? Jupyter hubs, yes. A few shaking. Oh, so that's super interesting. Okay. So one thing that becomes clear is that, would you jot stuff down? Do you mind, Dion? Besides being all the things Dion said, I guess also his PhD advisor. So is that all right? Yeah, or in notes, I want to capture it.
Okay.
Yeah, it's fine. However you want to do it. Other thing to say is I have to go teach it. What do you have?
They might learn the value of Jupyter Hub.
Yeah, no, that's true. But I mean, but what's interesting about that point of view is about that information is that students coming in to use this sample, are there students who are coming in who have used Jupyter hubs relatively your first year?
Yeah.
But anyway, there's a substantial portion, at least in this class, that just have never done this before.
Correct.
Got it. This is something that we do in the Momentum, in the boot camps, right? It's good to know that this remains up.
Yeah.
Can I ask a clarification question on the temporary access? Is the problem that it's sort of like that it is only temporary, or gaining the access, or like renewing it afterwards, or like being unsure about what happens afterwards?
Yeah, there's not a clear like README or
Okay.
doc on how to go about doing it, and there were sometimes there might be a 4-week period where the student would be doing something using LEAP resources, but it might take 2 weeks for approval.
Okay.
So some sort of clear path, clear explanation on on how to do that, and some way to escalate or elevate requests if you know, it is temporary but potentially impactful stuff that could happen with respect to leads.
That's very helpful. Thank you.
Yeah.
Just anecdote on that topic. So I was taking 2 classes at the beginning of this semester. One with Galen McKinley and one with what's his name? Right. Yeah. And like, so Galen, like, she knew whatever that process was, and so she got people, like, she got the entire class signed up like right away. But then I know in the class with Conrad, it was like very messy and took a long time for people to actually get that access. So it seems like there is a happy path, but especially like even during like add drop period, when people are evaluating whether or not they want to use the resources in the first place, being able to turn that around quickly would be helpful and made a difference, I think, between those 2 classes and continued with it.
So that's super good to hear. I want to come back to this question I asked before, and this could relate specifically to LEAP, but it could also relate to those of you who have done fairly large-scale computing projects of your own. And here you could substitute what I'm saying for LEAP Pangeo for like cloud resources, even generous cloud resources. And the question is that what you use? Do you use other things? And if so, why? I know you have an answer to this, and I know you have an answer to this, so I'm going to pick on you if nobody says anything.
I'll chime in. For me, I use the high performance cluster, the HPC of my department. So I do that instead of LEAP's cloud resources.
Why?
Convenience, I would say I actually got access to the resource before I even matriculated at Columbia. And then since then, I've just been using it. My data is there. So, you know, I don't want to port over the software and the files that are there. And I've not needed more resources so far.
You handed to Prani. Oh.
Hi, okay. I don't use resources outside of LEAP, but I think I need to at this point because some of my computations are just too big for the LEAP servers at the moment, it seems. Or like, I'm also dealing with this issue whenever the kernel disconnects or something, like everything stops. I can't really like submit a job and then walk away, go do something else and come back, which I have been able to do in the past. And it's kind of getting to the point where it's like impeding me more than it's helping me progress, I think. So yeah, I'm thinking about maybe using Gyre or one of like Lamont's, I don't know, servers.
Can I quickly follow up with a question? Is this mostly GPUs, using GPUs or scaling out on CPUs? Both. Okay.
I have access to the Leap Jupyter Hub. I don't typically use it for this exact reason. I think you're working on this, but like being able to like launch a bash script and then walk away is the main reason. And then also I sometimes parallelize things and use multiple GPUs at once.
Do we have access to them? Multiple GPUs at once.
Not yet, no. Not for the interactive compute. You get that for the batch processing, and we're fairly far ahead on that, but like it's good to oh wait.
Press the button.
Hi, I'm here from NASA GIS. So I use NASA GIS's computing resources, but I have a lot of colleagues who are doing their postdocs there, and they've done their PhDs and are comfortable with their own coding environments and backgrounds on their local systems. And while it might be more useful or they might work, you know, more quickly on NASA GIS's resources, they don't want to because they don't want to like learn how to use new environments and maybe a different IDE or different setups.
Can you clarify, is that for the kind of thing they can do on their laptop or their desktop, or it's for something else?
Yeah, on their desktop or laptop, or a similar situation, their other institutions, departments, resources.
I think it's funny about that, by the way, is that Dion says this is his department, but it's actually the entire university. It's just that applied physics and applied math uses the bulk of that machine. That's the entire, it's right. Yes. So this sort of persistence and a learning curve.
Yeah.
That looks high.
Yeah. Or like specifically with our resources, there's certain things you can't do and that you have to, find a workaround for because of the, I don't know, the size of it and maybe some limitations it might have because there's so many users. So learning how to, be more communal in a way.
Is that an issue that the Jupyter Hub solves a little bit?
Does to a degree, yeah.
Yeah, I guess maybe just as a public service announcement, that's kind of the point of the Jupyter Hub, is at least that's sort of one of the things that you can sort of be isolated in your environment. There are some limits. If everybody spins up a ton of compute at some point, our cloud account will sort of just say no and you won't get the compute, but it's you won't have the case really where your work affects someone else, as it sometimes is on a sort of shared server.
Stuff about computing. Could we have the same conversation about data? I'm really curious to know how many folks have used data that, one way to say it would be it's in the LEAP data catalog, or another way to say it would be, it's publicly available in some way that you found that was easy to access online. So meaning that I'm not so interested in having to download big quantities of data. So how many people have used data out of the LEAP data catalog? One. Can you tell me?
I used it for the ML class project, just pulling some of the data and verify.
Okay.
I think the nice thing about using cloud, like accessing cloud optimized analysis ready data, is that it makes this issue of trying to move your workflow from one place to another a lot easier. Not just, yeah.
But okay, so let me ask this. How many people have used big data sets to do their work? Many nods. But not stuff that's in the LEAP catalog. Why not? I mean, so like, maybe there's two ways to answer that question. One of them would be, why isn't it in the LEAP catalog? Right? Did you not think it was general enough, or something? I guess.
Also, I think we should define big. That might be.
Well, you're the.
It's like, how big are the data sets you're working with? It's like sub petabyte, a few gigabytes. Like, I think that means different things for different folks.
Well, I don't have a mic. I'll try to speak loudly enough. So it's okay. Hopefully, thanks. I can only report on behalf of postdocs of mine and who aren't here, unfortunately. However, I repeatedly hear that it's very tedious to, and I don't know what this means. I apologize. You guys will, to convert into ZAR format. They regularly use the word tedious with me. I don't know if that means converting data into that format or reading data in that format. I do not know, but they have never been excited.
No, I would agree on that. Like, as the person who is with the rest of the data and compute team, I think spends a majority of time is converting that. I think that is an absolute issue. I think, however, that it's sort of a bit, there's always a big question of like, you're doing a service for the community. It's a bit of sort of a delayed payoff. I think that's the way to think about it. But I will acknowledge that it's not a one-click solution of like, bring your data set. And the reason for that is that there's almost no standardization of like how people serve their data.
I see.
So just there's just so many different parameters that every single data set we think we can just ingest in an afternoon, we'll just have some other hiccup because, I don't know, there's just like the servers are throttled in a different way, or the files are arranged in a different way, et cetera, et cetera. So that's, I think it's a bulk of the work that we're actually doing.
It requires presumably a lot of human intervention to proceed through this process, I guess. It's not some sort of a recipe or bullets.
It is a recipe, but actually like defining that is like, that's the hard part. We're trying to ingest as much data as we can in a way that we can sort of re-execute and sort of fully separate the logic of putting the, like getting the data from somewhere, putting it together, and then writing it out to a ZAR store from like where we actually store it. But that is actually like the work of that is quite a bit of time of like the data and compute team. And I think it takes the way to think about it, I think, to like maybe be a bit more positive about it, is to say like you're doing this work once and then you never have to deal with it again. If there's a functioning recipe for your data set on the NASA DAC somewhere that works, you can always just like ask one of the infrastructure people over here and say like, I want that at a different location, and we should be able to just rewrite it. The second problem is that a lot of data sets are just not publicly accessible. There's sort of like a big pattern of like where data is on an NCAR, GIS, I don't know, like some HPC center, and it's not, you can pull the data out. You can only log yourself in and then sort of push the data out when you have access. But that sort of breaks this paradigm where you then have to do that each time you want to bring it to a different location. So you're continuously on the hook for it. I think it's a little bit of like small investments that keep repeating over time for everyone who accesses that data set. So a lot of this like cloud data, I think, really has to pay off when the data sets are used by many, many people and are very large, something like ERA 5. I think it's like, now we have just a link to it, and you could like, we didn't even do that. That was Google research engineers that did this.
Yeah, I mean,
You go ahead and turn it on.
right, yeah, so just to follow up on that. Okay, yeah, sorry. Just to follow up on that, I think the ERA 5 point is interesting because that only came online recently via Google, like maybe the summer. So before that, I would just download a bunch of ERA 5 from the Copernicus data center, which is great, by the way. But I think to your point about NCAR, there are certain model runs where it's just so much more convenient if you have an NCAR allocation, which I do, to just go to NCAR, take, copy it from whatever directory the runs are already saved at, and then, copy it to my personal directory or just link it there and then do the training there. Of course, one problem I ran into is that if I wanted to share this with a collaborator who was not at Columbia, but was eager to do machine learning and help out and carry the project further, that was a problem. And so I think we need to figure out what the best is across collaborations, because LEAP is a multi-university collaboration.
I do want to say one thing, which is that I want to stay a little bit away from trying to envision solutions right now. Like just because I'm curious about what works in practice, what works and what doesn't. Right. So
But having model runs on NCAR saved in the directory that I can just access through my NCAR account is great.
yeah, so it works if you have the access. I guess that's what I heard you say.
That's the only point. Yeah.
Yeah, exactly. Other folks, I mean, you have this experience, maybe I would point out with this cloud botany. So
So I'm working with this data set, and I would call it the ideal access pattern. It is so easy and wonderful. The cloud botany data set is part of the larger Eureka data set. It's all available via a data catalog. I can lazy load any of it with ZAR in seconds. It's terabytes of data, and anyone who pip installs the package can do this. And I mean, I feel like oftentimes at the start of projects, I spend a week or two or whatever trying to get access to the data for, in this case, it was minutes. And so I appreciate whoever the team that made this data set publicly available. And
so I was part of that team, although I was doing it on the experimental side. I promise you that took months.
of upfront effort. So this was, just for background, it was a big field experiment for which there are a whole bunch of large eddy simulation runs. Preparing the data, which comes, I mean, if you think model data is non-standard, try looking at stuff that comes off an airplane. Oh my God. And it just took like all this cleaning, all this homogenization, all this standardization, pushing back. And also if you think the modeling community is not open to standardization, you should go talk to the observationalists, the people who go make measurements. Anyway, the point is it took a huge amount of effort to do that. And so it's great to hear that it works.
Hi, everyone. I would like to share my experience before moving here. I was working on like an ocean foundation model for the Mediterranean area. And we used a lot of data, a lot of reanalysis data, but also analysis and simulation. And I would like to emphasize a couple of things. One is, there are some operations that you have to perform for like normalizing or standardizing data. For example, computing like a climatology or, the mean and standard deviation over a very long series of data. And you need some, functions or some efficient way to do that. And the second thing is that for when you work on data, you at some point you should decide whether it's more convenient to compute or store data. I mean, if you have to remap, for example, the entire data set, you can do it maybe online on the fly, or you can decide if it is more convenient to store the data. And I also agree with the first point about the ZAR format. So I have experience with ZAR, but not during the training of the model. I use, for example, binary Python files. So each data, hourly or daily data has been transformed into a Python binary file. So just to share with you this a couple of things. Thank you.
This is a great point. So I guess I understood the first part of what you were saying. This is a choice you have to make. Maybe it's not clear. But one thing I understood you to be saying at the beginning is these tasks that you were doing were probably done by other people also. And yet if you start with the fully detailed, model and you want to compute a regional mean, you have to compute it, and so does the next one, and so does the next one like this. Yeah.
I think that's why maybe in WeatherBench, they provide also files for like climatology, because it's easy, computationally easy to compute the climatology by yourself. So it is like ready to use.
Other comments about data? I guess one question I have, so for example, we haven't brought this cloud botany data set into the LEAP catalog. That's something we could do. It's easy enough to add a catalog entry. Are there other, how to say this? Like, are there other big data sets that people have worked with and they've said, I'm gonna just manage that big data myself? Everybody who does something big brings it into the LEAP catalog?
Hi, yeah, I'm a postdoc here at LEAP, and I don't use LEAP NGO. I mostly use like NCAR or other institutional HPC because like the data issue mainly, because we have like ensembles of LES data. I'm not gonna bring that onto LEAP NGO.
So can I just ask real quick, why not?
Because I don't find the utility of doing that, because it's like terabyte scale, and it's not at a process level where I think people would find that useful. Maybe this goes back to the point of like the lifetime of data, from like the raw data to like a final archived set where people might be able to use that. And if it's somewhere in between, it might not be like useful to the broader community. Yeah.
And so because it's hard, it's not, because it's tedious, you don't want to do it.
Yeah, it's just too high of a hurdle to do it currently. And also, I also use like large image data set. So it's like like hundreds of gigabytes to terabytes of images. And it's like a raw unprocessed format as well. So like, I don't see how people might even use that at this point because there's no description of the data, or it's not in a nice, tidy format for people to use.
Can I ask about the large ensemble data? Is that sort of like the published kind of large ensemble data, or is like something you have sort of?
It's preliminary. That's
Okay.
why. I mean, maybe if it gets to a point where it is published, then we might want to give like a clean kind of archive data in the Leap Pangeo, but like it's not there yet. So that's why I have no interest in doing that personally myself yet.
No, I think that's super helpful, actually. I think that's sort of like, it's important to distinguish between sort of data sets that are published and sort of versioned and fixed and stuff that everyone is working on themselves. And I think then the point about like not collaborating on it actually does make sense to a degree.
All right, it's 12:30. Oh, sorry. Did you?
Oh, I had a question, but it's.
Why don't you ask your question while I'm spinning these things around?
I actually haven't worked with Leap. I'm more here to like understand it, but like I did have a question based on some things that I heard. When you bring data onto the platform, is there any sort of like validation process that it's supposed to go through beforehand? Like how does that work?
So the idea of like most of the data that we have in the catalog is actually that we're just transforming another data set into a format that is easier to access and more performant in the cloud. So we're not actually modifying anything about the data set, neither the values nor sort of the metadata, unless there's sort of an informed decision by someone who knows the data, then we can sort of change something around, but it will be obvious in how we do that. We don't do that sort of behind the scenes. You can sort of look in the code and see what was actually changed. And we'll always sort of reference the full provenance of the data set. This breaks to a degree, I think, with data sets that have not been solidified somewhere. And so that's, I think, an active area that we're thinking about. But generally, the data that we ingest, or we call that, is either we just literally link to something that already works in the cloud, or we transform it and store it in our own cloud storage.
All right, we have to switch gears. But although thank you, this is super interesting. Partly, this is like informing what we write in the proposal, the renewal proposal. Okay, so just to be like sort of mercenary about it. The other idea that we wanted to bring up, this is Chan's idea, so we can thank her, is this idea of trying to nucleate or crystallize some communities of practice. And I had a couple of ideas that came out of the annual meeting, but these are meant as seeds. And if they don't work, that's fine. But really what I want to hear is what your sort of pain points are. One of them was around reproducibility. So at the annual meeting, the goal of science is to be reproducible in substantive ways, not in trivial ways, but in substantive ways. And so, by which I mean, if you store the data that you use to make the plot and you provide the code to make the plot, that's trivial, right? You want to do something which is more substantial. And we heard that we splattered on reproducibility with respect to the machine learning components of Leap in a reproducibility audit that Chan and Christina, did I get the name? Candace, sorry, that Candace did. Sorry.
But just to be, I'm sorry. Just to be clear that we didn't expect to reproduce anything.
Yeah,
but we actually some successes. We noticed some successes.
I guess my point would be this: there are probably people within the Leap community who are interested in enhancing the reproducibility of what they do. That could be a community of practice where people get together and say, this is what worked for me, this is what did not work for me. Maybe you wind up providing templates or guidance. Maybe you write something, right? This could be one possible.
So the community of practice can move from a desire to be reproducible to actions. Exactly. Where we can work together and help each other, and by sharing what works for. So this way we don't have to reinvent the wheels that some other people already figured out.
Another one that came out of the annual meeting is this idea of data storytelling. So Gayla McKinley showed the work that she had done with Carbon Plan and Thea Heimdahl, showing, generating something which was meant for public consumption that had splashy graphics, but basically was a way of doing some instruction to the public in her case about the science she was doing. So this is a possibility. One other that came up in a conversation again with Tian was running Model X. So in our case, in Leap's case, it might be CESM, which is the global climate model from NCAR that we are focused our attentions on, but it need not be that model. It could be something else. And the last, or another idea that I had was about training ML models. And in particular, I have in mind stuff that is happening at scale. So very large, very complicated training, stuff that is bigger than a class project. So these are 4 ideas I had, but I'm curious maybe to ask. So these are really meant as like seeds or stimuli, right? I'm curious to ask folks, what are the technical tasks that you undertake as part of your Leap research, let's say, where you wish you had friends, right? Where there's other people that are suffering in the same ways that you are, but you don't know who they are. Or where like, this is so stinking technical, I really wish this task was easier.
So before we go into the question about where you wish you had friends, also about making friends from scratch. So in the previous 2 topics, and I don't know if it would totally overlap with this one, but not just pain points, but entry points.
Oh, so you're so good.
Yeah. So that entails making friends, right? I often will get a question. I'm like, well, I'll point them to Julius, and they're like, well, or I'll point them to the website. I'm like, well, the information's not there. I don't know what to do now. What do I do? And so, and that's hard because they don't have the friends, right? They need entry points. We need a way to define entry points.
Yeah, this is great.
Can I add to that also successes? I think if you actually figured something out, it's really cool. Like if you share that and I just make it available to a broader community. So I think all of these 3 are like really, really good points for each of the communities.
There's a granularity to this. So for example, there are people in my group who run CESM on Tian's supercomputer. And it takes some fussing around to move to a new piece of hardware. And so this was a staff member who did this, went through and said, these are all the changes I'm going to make. This is how you do it. This is how you get the allocation on Ginsburg. These are the files you need to change. Now this is how you build and run the model. And that's all on a public facing GitHub page that I'm sure nobody ever has found.
Along that line too, so running Model X. So for instance, Sam here in the class is very interested in visualization, new ways to make really nice visualizations of climate data. A couple on that side are also interested in economic connections with climate. So presumably Model X could be something beyond just running like the typical model, right? We're thinking of sort of visualizations, right?
Well, why don't we just say, doing complicated task. So that's right. I had this in mind because that's where I come from, but that's a general thing, right? If you have something which is complicated to set up, which involves a lot of dependencies, which takes a lot to learn, an entry point here.
When you say that, do you ever wish you had a friend? And I feel like that's like every day. When I read papers from the climate science, when I try to make sense of the data sets, I always wish there's somebody sitting next to me where I just ask. And currently that friend is called ChatGPT, but I think I can find a much better friend from the center. Like Greg knows that in year 1, every time I run into him, I just always quiz him of what does this mean? What does that mean? But that's a kind of thing that a community practice can facilitate, that make the experience more efficient.
The one thing I want to say here is, at least for this conversation, I want to focus on stuff that's kind of technical, where the data and computing can support.
Yeah. Sure.
You guys all have enough friends? Or do you think your task is so specific that no one wants to be your friend? One sec, Sam. Go ahead, Tia.
I wanted to chime in and share a happy experience, actually. So my current research really makes use of this ML-like method called equation discovery. So what happened was that last semester, I gave a lead research update when I basically shared all my research. I say, I need to do equation discovery. And right after that, Viviana actually reached out to Robert and I to recommend this package called PySR. And of course, meanwhile, I also knew that Lozana and Sarah are experts in equation discovery. So I already reached out to them on the side. Part two of this story actually is that, so at the recent LEAP annual meeting, I gave a lightning talk where once again, I spoke about equation discovery and the challenges I face. And after that, it turns out that a whole bunch of other people face the same problems. Not only that, many of them also use PySR actually. And so I had quite a few conversations along the side on that. So yeah, it was I guess a good thing that happened.
Right, so this is the kind of, I mean, maybe it's obvious to you guys, maybe it's not. Like, this is what it means to be a scientist in a community. You find people solving the same problems or asking the same questions, and you get together with them. Question is there something within the center that we can do to facilitate that outside of, or in addition to the normal sort of socialization? Did you want to say something before
Yeah. All right. I've had some previous experience working with basically a sort of central cloud notebook provider. And one of the really interesting properties that it had was that it was basically like all of the notebooks were public by default to the community that I was in. And it was really helpful sometimes because if I was looking at a problem for the first time, I could just be like, oh, is there anybody else who's done anything remotely resembling this? And I can, look at like, oh, what are the libraries that are being used, or what are the techniques that are being used? And then if I want to go and talk more to that person, then I can go find that. I don't know enough about the current LEAP like catalogs that exist, but we talk about like, oh, I have this like intermediate data that I'm not really comfortable sharing yet. I think that's actually an opportunity to like other people are probably at the same intermediate steps that you are. And if it was easier to just like look around at what other people are doing within the system, then perhaps it would improve this sort of ability to find people who are doing the same things that you are.
Thank you. No, to Dion's point, I think it's good to hear that I've had some issues with PySR too, so maybe I should join this community. But I'm going to make a shameless plug. JSAG, and I know Joe's here, so if you want to add something, do so. We're having a climate ML methods workshop next week, which was born out of like a similar sentiment, which is there's many cool things already happening in LEAP or LEAP affiliated groups. And there is a good chance that you may have talked to that person or met them at the annual meeting, but you've not had a chance to hear about the work that they're doing in some detail. And so Dion, this is also, if you want to share about your PySR experience, we can talk offline. But so this is happening next Friday. Please do join. So, And we hope to make these a slightly more regular occurrence. This is the first event of its kind. And maybe we can catalog all the notebooks. So this goes to the previous point, and maybe, share this through Leap Pangeo.
You schedule this for the day after the presidential election. That is great.
November 8th. So that's next Friday.
Oh yeah, a couple days. Sorry.
It was November 7th. It was November 7th in 2016. I remember this because I was teaching next day, and it was atrocious.
Yeah. Anyway,
Okay.
high anxiety. So let's Ronnie and then Maggie, and then actually I'm gonna take off, and Julius is gonna keep going because I have class on main campus.
So you asked kind of what Leap could do to like foster these scientific friendships and such. As an early PhD student, I feel like there's a lot of, and I feel like this is also true. This is true for like master students, maybe PhD students who are like starting out in their first couple years, and also whichever undergrads tend to be around RU students. It's like scary to talk to other scientists. One, because we don't know everyone in Leap yet. Like I feel like I'm still like getting everyone's name. And so sometimes it's like, okay, well, I know this person works on oceans, but I don't know if that person is doing like the type of ML work that I'm doing, or if I'm struggling with like I end up struggling with more technical things. And I'm like, okay, well, who do I go to for that? So it's not always very clear who to go to for help. And I think there's also some level of intimidation in that. So I think what would be helpful is I know like Leap Pangeo trainings happen regularly, but I don't know, and M Squared Lines does some version of this where they have like early career researchers get together and like they all talk about their research and help each other out with things. And I wonder if we could do something similar at Leap with like junior budding researchers. As in like we could like if there's like I don't know, someone who's like further along has a time or something, we can just like sit, have coffee, and then like ask them a question or two.
That's a terrific idea. It's a little distinct. It is a great idea. It is a little distinct from this idea of sort of communities of practice around something technical.
Okay.
Right, so I can share what the community practice does, maybe.
Maybe note this for the EC or something. I think it's a great idea.
No, I agree.
It's just like, it's not really data and compute, but like, I think adjacent to.
So a community of practice is the model is you have regular meetings. And then at the meeting that you have certain, you could have almost like a meetup, right? If you think of meetup is often used as a community practice. The idea is that people will gather around a common interest. In this case, is data and computing, and you have regular meeting maybe once a month, twice a month. And when doing that, the conversations surrounding that. So that naturally address the new person dilemma, that when a new person come to community practice, they will obviously introduce themselves, and then also the rest of people will introduce themselves, and then people can work together on common interests. You can say this meeting we can look at a data set together. The next meeting we can each talk about how we manage our like computing environment or something. So they naturally need to have someone who lead, but the key is people contribute to the community practice, and then they at the same time receive the value of the community practice. It's like the common good. You put in and you got out. For the question about the junior to junior, I think the GSAC is already doing a great job of organizing events. I think I always said you guys should have a monthly lunch. I'm fully supportive of that. I said I already shared my support the last time I meet with you guys. I think that can be a very good starting point. I also love the idea of the climate ML method workshop.
I just want to briefly say we kind of do the monthly lunch already. So maybe we haven't done a great job communicating that, but it's like an open community for any young scientists. So like if you haven't joined, please join, and we would love to have more participation in that. So
it's a little bit in the weeds, but I feel like for thinking about training ML models, I often need help not with like, okay, actually, how do I, run this, but how do I manage the whole workflow, right? When you're building an ML architecture, you're not running it once. You're tuning, you have all of these weights and biases. So like, I know that there must be a good way to do this, and instead I'm like trying to figure it out on my own. So I feel like just talking not just about like the model side, but the like whole workflow organization would be useful.
I'm gonna jump in with some comments online. Yes, one. Adisu said reproducibility is my major concern. I think it's good to consider tasks like experiment tracking and documentation. I think that goes to being able to transfer knowledge. If you've run something before, having that documented so someone else can follow it and be able to recreate what you've done. Viviana said, would it be helpful to have a spreadsheet-like list of LEAP members with interests or skills so others could know whom to talk to about a particular problem? I think that would be immensely useful for me.
I can just speak. Again, I mentioned I haven't used Leap before, so I'm sorry if it's not the most beneficial, but as people were talking, I would just start to think like a lot of times I think when people are like doing technical work, you're so caught up in what you're doing that you don't necessarily have the immediate thought of like, I need to ask someone that like I need to ask someone this. I've noticed a lot of times when people are more technical, it like things like Stack Overflow like explode, like everyone's helping each other on Stack Overflow and things like that. So I don't know if you guys have like any sort of ability to just have people ask questions on like a public board and be like, hey, like this, because I think that automatically also ends up forming like people who look at other people and like, oh, this person is struggling with why, and like, and very much in the moment too. So that's something that I was just thinking about as like this was going on, but yeah.
We do, but it's not very heavily used. You have like this GitHub forum. We can like happy to take suggestions of like, I think there's a bit of a straddling a bit of the line of like getting people to speak up, which I think is harder if it's sort of like what I would call fully public space, like Stack Overflow, or if it's sort of within the community, the GitHub organization, that I think we can control a little bit more, that like sort of nobody like acts mean or anything like that. But I think, yeah, I would like that to happen a lot more. I think there's a lot more things that we can surface in a variety of different ways. So I think like what I'm hearing a lot is sort of that we just need to establish more channels of connection and just actually exposing what everyone is doing on the technical level, which I think like on the scientific level, we're doing, but I think this is very helpful to sort of achieve that on the level of the technical challenges that everyone faces, which might be sort of differently connected than the actual science.
I think so. There are a lot of ways for people to ask questions currently existing. For example, we have the Slack channel for the PanGO. We have the GitHub forum that Julius just mentioned. However, we shouldn't underestimate the value created by a session like this. Like people now using any technology and just speak their mind, what's on their mind, and just they don't need to know how to submit a question on the GitHub request form or something. Like even if eventually it will be always a good idea for any questions, any requests you have about LeapNGO, you add to the GitHub. It's nice to have a place like this when people just, can say their mind or what they're wondering about, because that models humility of not knowing anything or not knowing how to get started. Like I sometimes feel in order to ask question, you need to know certain in order to formulate your question on a public forum, you sometimes also need to have a familiarity with that thing to a level. So sometimes that level is hard, but having an environment like this, like if we do something like this every month, I'm sure that we all can learn how to communicate better.
Okay, I'm a first year PhD student, so I don't really know LEAP at all. I'm coming from economics perspective, so mostly climate impact stuff. But for me, a data community would be really useful because especially within economics, we don't really have the same advising model as like natural sciences. So we don't actually have an advisor for a while. So like just even hearing that there's like some sort of data hub within Leap was new information for me right now. And I think like knowing what data is available and how to access it would be super helpful.
Is this more for interdisciplinary, or do you think like in general, sort of like a?
It's certainly interdisciplinary, but I'm fairly certain there's a lot of information just within what Leap is doing, like what data you guys are using that I would benefit from. Like it wouldn't have to be interdisciplinary.
And also we have to be mindful, some of the graduate students who find their way into LEAP with the interest to collaborate, this may not be their main thing. That may not be their dissertation, but they're interested enough to develop interest. So for this venture of theirs, they don't have a faculty member who will hold their hand all the way, just like we just said. So to do better on the sharing side could go a long way.
Just sort of a short comment. I think like the data catalog is in the end sort of like gonna start that. I think it's a good idea to sort of like have maybe a group that discusses new stuff that should go in there. But the idea of that is sort of that we have a central sort of entry point where people can browse and filter out data sets and sort of look at them in a quick way to sort of figure out whether they work for them.
Yeah. I mean, just to reemphasize, I think we started talking about pain points, but I think pain and entry points are really, really crucial.
Yeah, I'm not sure if this is relevant, but from my personal experience, like with regards to communities, I think projects where I'm collaborating a lot forces me to kind of like write good codes and, you know, kind of like, because the other partner is kind of like depending on my code and how you access the data, how you process the data. So that's kind of like a natural incentive for you to kind of like make it reproducible instead of like you working alone and it's like, it works for me on my computer kind of situation. It may not work for other people.
Could this be described as sort of like a peer review, like peers as in your community peers, as like you package something, you have like a notebook that you want to like share with people, and people just like volunteer to come to a group to sort of just run through it and give you feedback. I think that would be that'd be amazing. I like that.
That is a great way of learning how to make your own notebook reproducible. For example, if Juan has a notebook for the upcoming bootcamp that needs reviewers and volunteer to help him reviewing that, would allow you to see what Juan did smartly. Like you can say, oh, that's a nice trick that I can learn for my own notebook. On the other hand, you can help him, you know, identify all the potential unforeseen technical issues and then help improve the notebook. By the end, you learn something and he has an improved notebook. And then that's what this community practice can really serve each other. And then we're all going to do better science that way.
So just a little plug, we usually have this monthly hacking hour where we can definitely sort of like have a lot of room to like accommodate different scenarios if people want to present something, and we just like give feedback right on the spot and like hack on it. That's totally a possibility. So like just please join us for that, and then we can so like I don't know when the next one is, but we'll announce those on Slack. So watch the Slack channel. Thank you. It is also in the newsletter as far as.
At the bottom?
Pardon me?
At the bottom of the list of activities.
Don't actually know, but I'm pretty sure it's in the newsletter and it will be on Slack.
Good. So yeah, I certainly belong to the people that are more like LEAP affiliated or like associated. Since I'm only here for a research stay, I don't really know actually what I have access to and whatnot, or could get access to. So I just wanted to bring one point in from basically where I'm usually located in Valencia, because some people were talking about they didn't really know what actually is available. What is the stuff that you have and offer? And we have something we call like La Finestra Única. So the single window, which is basically one kind of sheet that gives you an overview of everything, right? That you can, once you're on board, once you start, you can just click yourself through this and you have seen everything in some sense, right? So you don't need to search. Everything should be connected to this window. right? So maybe that's an idea, like something you like maybe can establish so that this doesn't happen where people are like, you've never heard of this.
No, I think that's great, and I think again that's sort of the LEAP NGO technical documentation is sort of, at least in my mind, is that if there's like it's certainly hard to have the catalog of everything. That requires a lot of maintenance, but I think the one thing that would be very useful is sort of if that is sort of advertised more as the entry point, and then people report when they get stuck on something or when something is missing. That's sort of how we can drive that document to, or the website to, become a lot better for the next person who comes in, and it also provides a bunch of different perspectives and not just the 3 people who maintain the documentation. One more, and then I think we wrap up.
Hi. Hello, I'm Joan. I'm a guest, so I'm not a student here. So I just want to ask a question with regard, I'm coming from a data end user's perspective. So has anyone done climate scenario analysis? Because I work for a financial institution and we use a lot of climate scenario analysis to revalue our portfolio. So climate is very important today. There's a lot of emphasis on how that is going to impact on investments. So I'm really curious to know what you do with the data. And with regard to the community, do you extend that to non-academic such as me, where I can access to the great work that the students are doing, and some trends or some ideas of what we can work together, for example? I'm question to maybe the lecturers and the organizers.
So some here might not quite know how scenario is defined. Do you mean, so if you take this trajectory with greenhouse gases, that this is the scenario? If you do this trajectory, this is a different scenario. Is that what you mean by scenario?
Yes, like the 1 degree, 1.5, 2 degree, according to the IPCC, the 6 assessment study, where we actually would look at how the world would be in response to how the climate changes and all this extreme weather conditions that's happening around the world, and how does that impact on assets, for example. I'm not sure if this is the right forum. Like I say, I'm just a guest. I'm curious and very interesting to hear what you guys have been sharing so far.
You might not be quite to that point of doing that yet. We're sort of here building new models that will allow us to better quantify the outcomes given a particular trajectory, both a combination of naturally, what humans do and so forth. So trying to get a better model that provides those trajectories. But I don't know that anyone here would be doing that, such an analysis yet. I don't know if you're aware of, yeah, but I think that would be something that as LEAP progresses, would be something, and we do have models that can start saying what would happen once we advance them further.
Yeah, I just want to add that is a really big pain point for us. It's aggravating us every day, realizing, wondering what to do with the investments according to the climate scenarios. Something for you to work on, maybe.
Maybe one pointer is that I'm actually working on like bringing the raw data, which I think you're asking for a derived product or something more along sort of a risk prediction based on many scenarios. But I think one way to make that easier is like, and that's something I've been doing for a couple of years, is bringing actually the original CMIP, the projection data, into cloud storage so that you can actually analyze them fully publicly on your laptop right here on the LEAP NGO hub, and you can basically perform like the IPCC report plots like in a few minutes, and then you can modify them. And hopefully, I think that it would be great if we get more engagement from sort of from the outside, how to bring these two things closer together, and what would be a useful tool that we can layer onto that sort of analysis-ready climate data that would then actually produce a useful product for a community like yours. So I think that would be helpful feedback. All right, I think then we're at time, and probably continue chats if desired over a slice of pizza. Is that over there?
Yeah, thanks, Julius. So everyone in the class, if you would, as we've been doing, would not mind going first, just so we could get to our discussion. Thanks.